Hello, Legacy Sabers. Marsh here. So today we're going to talk about graphing and writing ellipses translated. Again, you want to find that conics foldable, and you're also going to want maybe a calculator and then also some writing utensils of some nature. So last time we met, we talked about ellipses that were only centered at the origin. Now, what if I decide to move my ellipse? So if I move the ellipse from the point HK for a center, so now this is what we looked at last time. Now I have this H and this K that we're going to have to start worrying about. Not difficult, but it's just going to kind of move it around a little bit. So again, we are in the ellipses tab of our flipbook. And let's talk about how to figure this out. So first thing I need to do is I need to figure out which way is this guy facing. Is he a horizontal major axis or vertical? So is this ellipse going to be short or is he going to be tall? In this case, since the 49, the bigger number, is under the X, I am going to have a horizontal major axis. My center, it's going to be opposite signs again. So my center is 3, 5. I'm going to put that as my dot here. 3, 1, 2, 3, 4, 5. So 3, 5. This is my center. Notice I'm labeling it. I'd recommend, it's not required, but I like to label my center and stuff. Let's find our A and our B and our C. So A, B, and C. Remember, A is the square root of the bigger denominator, so 7. B would be 2. And then C, remember, is the foci to center, and it is a squared minus b squared. That's how I find my c. So a squared minus b squared equals c squared. So 49 minus 4 is 45, square root of 45, which is 3 square roots of 5, correct? Which 3 square roots of 5, I'm going to use my calculator here quick. I'm going to figure out what that is as a decimal roughly for us. Otherwise, we're not going to know. 3 times the square root of 5. 6.7 roughly. So 6.7 is what that is. So let's go ahead and find our vertices. Now remember, this is a horizontal. He's under the X. So I'm going to go 7 left and right for my center. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. These are my vertices. Those ordered pairs, we can label them. -4, right? 5, it looks like, right? No, yes, 5. -4, 5, and 10, 5. That's what that looks like. The co-vertices, remember that's the B value. That's how much I'm going to go up and down. So I'm going to go up 2, that's CV. Then we'll go down to 1, 2. This is my CV here. So those ordered pairs are 3, 3 and 3, 1, 2, 3, 4, 5, 6, 7. 3, 7. Now, I can actually draw in my ellipse here, connect my outside dots, center in the middle, and then my foci are 6.7 away from the center towards the vertices. So I'm going to go 6, 1, 2, 3, 4, 5, 6, and get a little bit close. There we go, there's my F, and then something around here too. Now, those ordered pairs, kind of strange, right? Because it's not a perfect number, kind of like the vertice. So I have to be kind of fancy when I find the answers to my foci. Here's how I'm going to do it. I'm going to look and think, how did I start that ordered pair? Well, I started at the center, right? So the X value, the Y value is not hard. I know that the Y value for both of these is 5, right? You guys would agree with me there? It's definitely 5. I just don't know about the X value. Well, I started at 3, and then I went right 3 square roots of 5, and I went left square roots of 5. So I'm going to write that out. I started at 3, and I went right Whoops, sorry guys. Right, 3 square roots of 5. And I went left, 3 square roots of 5. So my ordered pair, 3 plus square root of 3 square roots of 5, comma 5, and 3 minus 3 square roots of 5, comma 5. Strange, but nevertheless, those are technically the ordered pairs of those dots. Now, let's talk about writing equations of ellipses. So go to the writing equations, circles, and ellipses tab of your foldable. And let's talk here. So I have this beautiful graph here. Let's first find the center of this guy. Looks like it'd be right here, right? That kind of looks like the center. So if I start writing my equation here, I'm going to get x. Oh, how is that? 1, 2, 3, 4. X minus 4 squared. I don't know what's over. Plus y 2 minus 2 squared equals 1. Now, I need to find A and I need B. Don't care about C because it's not in the equation. I just need A. Now, remember, A is the center to the vertice. So that would be, how far is this piece right here? So 1, 2, 3, 4, 5, 6, 7 for my A. And B would be center to co-vertex, which is 1, 2. Now, I need to figure out, where does this 7 go and where does the 2 go? Since this is a major axis of vertical, he's up and down, that means my A has to be under the Y. And it's not just 7 because we had to square root, right? So it'd be 49 here. And then this guy would get the 4. Okay. Takes a lot of thinking, a lot of processing that has to happen when we find ellipses. Now, what if I don't even give you anything? What if I don't give you a graph? What if I just ask you things? So we got a vertice of 2, 13 and 2, -1. Then we have co-vertices of 5, 6 and -1, 6. So what I need to first do, I don't have a center, right? So what I'm going to do is I'm going to find the center between 2, 13 and 2, -1, right? Because that would make sense. The center has to be in the middle of the vertices. So again, that midpoint formula, I'm going to go 2 plus 2 divided by 2. X's, I'm going to add the y's to one another. That's going to find me my center. That's going to give me, well, 4 divided by 2 is 2. And 13 minus 1 is 12 divided by 2. That's 6. So my center is 2, 6. So I'm going to start writing out my equation here. So I got x minus 2 squared over something. Y minus 6 squared over something equals 1. Now, let's find the A and let's find the B. So A and B. I was given the vertices. Remember, A is center to vertex. So I need to figure out how far is 2, 6, the center, from 2, 13. 7, right? 7 units away from one another because 13 minus 6 would give us 7. So my A is 7. B, again, is my center to my co-vertices. So how far is 2, 6 from 5, 6? 3, right? Now, I need to figure out which way is this guy facing. Is he a vertical ellipse or a horizontal? Best way I find is just to kind of do a little sketch. So 2, 13 would be something like way up here, and 2, -1 would be right down here. And then 5, 6 would be like right here and right there. So this guy looks like something like this. Notice he is a vertical major axis. Another way to look at that is looking at the vertices, the y's are changing. That's how you know it's a vertical. So I know that A squared has to be under the y since this is vertical. So 7 squared would give me 49. And then B squared has to be under the x, which is 9. Let's try one more together. So I got vertices of 4, 13 and 4, 3, and then I have foci at 4, 11 and 4, 5. So again, I need center. Let's find our center. Oh, not that kind of way, right? But 4 plus 4 divided by 2 and 13 plus 3 divided by 2. So I'm going to find the midpoint between my vertices because that's where my center is. It's in the middle of the vertices. So I'm going to get 8 divided by 2. It's 4. 13 plus 3, that's 16. Divide that by 2, that's 8. So my center is 4, 8. So again, just like last couple of times, I'm going to write out the start of my equation. Now, I need A, I need B, and I need, well, normally I don't need C, but I think I might have to use it this time. Vertices to center is my A, so 4, 8 to 4, 13. 5, right? B, I don't know my covertices. Can't find B. Well, foci to my center, which is C, remember, is 3. But C isn't in my equation. I need to get B to be in my equation. Oh, I have that equation though, right? A squared minus B squared is C squared. So let's plug in what we know. We know A squared is 25 minus whatever B squared is has to equal 9, right? C squared. So I'm going to solve here. I'm going to subtract 25 on both sides. Negative B squared is going to be equal to, well, 9 minus 25, that's negative 16, right? And then, 16. So B squared has to be 16. Square root both sides, I get a B of 4 in this case. Now, which way is this guy? Is he vertical? Is he horizontal? Let's do a quick sketch. 413 is way up there. 43 is right here. 411 is up here. 45 is there. And we know covertices is somewhere here. Since my vertices are going up and down, and so are my foci, that means that this guy is a vertical ellipse. So that means my A squared has to be under the y. So this would be 25. And then this will be 16 for an answer. It's a lot of thinking about what do you have and what do you need. Number 18, here's what I'm going to do. I'm going to make you guys do it yourself. So I'm going to have you guys try it, and then you're going to come back to me in class, and we're going to go over the answers so you guys can discuss it and ask me any questions you need. We are also going to do another graphing problem of how to graph it when it's been translated so you guys get more comfortable with that as well. Until then, though, that is the end of this video, and I will see you later, Sabers.